So on the review from Monday, there was a problem on the very beginning that asked which one was a chord. And they had an example, and I believe one of them was BC, and the other one said something about AC. And those are the two that you were confused which one really was a chord. And the reason why we're confused is because we haven't talked about what AC is yet. BC is a chord. A chord stops on the edge of the circle. AC continues. What that is called is a secant. Okay, a secant is like a chord. It just keeps going in both directions. Okay, today we're also going to be talking about a tangent. Just like the tangents we've already learned about, this is just another form of it. A tangent only touches a circle at one spot. It can only touch the circle at one spot. Okay, one of the biggest problems or issues we've had today is people thinking that something like this was a tangent. Does that only touch the circle in one spot? If it continued, would it touch the circle in more than one spot? Okay, that's called a secant. So a tangent only has the opportunity to ever touch a circle at one spot. Does that make sense? Like if I extended a line, it couldn't go through the circle again. That's what makes it a tangent. So today, when you're putting your tangents on your yellow circle, or sorry, some of the papers are white, this period, you need to make sure it only touches one dot, not two, okay? So, what I want you to do is on your yellow or on your circle page, okay, so on your circle page, I need you to be careful. All of the ones we're doing today are going to cross, but I want them to cross outside the circle. Sometimes when you do that, you have a tendency to run off the paper. So I want you to be careful, and I don't want you to run off the paper when you're drawing the segments for today. Okay? So just as you're doing them, if it starts to run off the paper, then try and change it to where it won't. Are we good? The yellow paper?
Yeah, do vertical. Same thing.
Okay, so on your first circle, okay, on your first circle, using your straight edge, I want you to create two tangent lines. Okay, remember this is a tangent line right here, right? Two tangent lines that cross outside the circle. So I'm going to be walking around to help you, but I want you to create two tangent lines. Okay, so if I have my angles here, what I'm going to do is I'm going to subtract my numbers, 270 minus the 90. Remember that's the measures of my angles here, my 90 and my 270. If I subtract those two arcs, okay, that gives me what, 180? Divide by 2, does that give me 90?
Possibly.
Possibly. 120 minus 30. That gives me what, 90? Divided by 2, does that give me 45? And again, 210 minus 60 gives me 150, divided by 2, which gives me 75. So in other words, visually looking at the pictures, if I take the large arc minus the small arc and I divide them by 2, that gives me my angle measure right here. Okay? Again, my large arc minus my small arc divided by 2 gives me the angle measure right here. Are we okay? So now I don't have to worry about actually measuring. So flip your paper over to the back and look at the one problem right here. I want you to try and find the measure of the angle. Find the measure of the angle.
No.
Okay, what do you think I would do?
Take the 150.
150 minus 30 gives me what?
120 divided by 2.
Divided by 2, that gives me
60.
Okay, so here's the first thing I need you to know. On worksheet 2 from yesterday, we only had about, what, 4 or 5 more problems left? That's the first part of your homework, is to finish those problems. Okay, the second part is the other white paper you got today. Ask you to write all the possible ways that 90 degrees can be formed using a circle. Chords, secants, tangents. At the bottom of that page, I need you to make sure you can read that says 57.5.
Wait, for which one?
Okay, on the back side of worksheet 1, the bottom right-hand corner. Make sure you know that says 57.5. I don't think you can see that decimal. It should say 120 and B. Uh-huh. And then the back side of that is worksheet 1. Okay? Right now we're going to look at our notes. So take a look at your notes for the day. Miss Ramsey, why do we have to do those stupid yellow circles?
Does it help?
So they help.
Why?
Because we're actually
Some of you learned visually. Some of you now understand where the numbers are coming from. All of you drew something different, and what I just taught you worked for every single one of you. You may be off by a little bit. That's just user error, correct? Okay, some of you memorized Pythagorean theorem because the teacher just told you to. You didn't really understand what it meant, right? When you got in here now, you understand some of those things. For instance, pi, did somebody just make those numbers up? No, they came from the diameter being able to wrap around the circle. Are you with me? So by doing these yellow papers, I'm helping you give an example, and you actually physically did the measuring to find out that every time you did this, you got the same process. I don't want you to have to continue to do that process. I want you to know the shortcut. But I also want you to understand where it came from, not just how to memorize that formula. Are we good? Okay, so tangents. Many of you use tangents every day. You just don't realize it. Those of you who have been playing baseball since you were little. Those of you who played baseball when you were little. Those of you who are in track that throws the discus. Okay, or the shot put, really. A tangent line. A tangent line is a line that crosses a circle at one spot. So in this example, it's the track and field person throwing the discus. I want that discus to go between the foul lines, and I want it to go to a very specific spot. So when they rotate around, when they release it, they want it to release it in a straight line so that they keep it between the fouls. Are you with me? I don't know what they're called. Are they called foul lines? The sectors? That's even better. Okay, we got it. I got it. Next one. Okay? But in baseball, what does your coach always tell you growing up to teach you how to throw the ball? Step towards the person you're throwing to, correct? Because they want that circle to go in that direction so when you release it, what happens if you release it too late? The ball goes where? In the ground. If you release it too early, where does it go? Up high. I want to find the right tangent point to make it go and hit the person I'm throwing to in the chest. Are you with me? Okay, those are tangents. Did your Little League coach teach you that? No, they probably didn't realize what they were teaching you. They just knew how to get you to do what they wanted you to do. Are you with me? Okay, but that's nothing more than tangents. Are we okay? Okay. There's two things I need you to know about tangents. Number one, a tangent line and a radius form 90 degrees. A tangent line and a radius form 90 degrees. And party hats. Do you know party hats? Like you get when you go to a little kid's party, they have a little rubber band thing under your chin? Okay?
So itchy.
On a party hat, okay, a party hat is nothing more than two tangent lines. And what I need you to know is those two tangent lines are the same. They're congruent. Okay, so when you see a party hat, you know those two sides have to be the same. They have to. There's no such thing as anything different. Okay? Look at number one. Somebody tell me, what is this line right here called?
Radius.
A radius? What would this line right here be called?
Radius.
What do you know about it? It's the same thing. It's 19, right? If these two are 90 degrees, doesn't that mean that these two sides are parallel?
No.
And if these two are 90 degrees, doesn't that mean these are parallel?
No.
So what shape do I have?
Square.
A square, so this side is
90.
19.
I didn't see that number.
That's okay.
I just talking about the angle still.
Okay, what's this piece right here called?
Radius.
A radius. What's this line right here called?
Most likely a.
The long,
tangent.
A tangent. What do you know when a radius and a tangent hit?
90.
90 degrees. Oh, great. Look what shape it makes.
triangle.
What kind of triangle?
Right isosceles.
So how do I find this side? Pythagorean theorem. 15 squared plus 20 squared equals x squared. So that's 225 plus 400. 625. So that means that this whole side right here is 25. Now, I'm going to give you a heads up of what they're about to start doing. Remind me again, what's this line right here called?
Radius.
Radius. What's this line right here called? A radius. How big is this radius?
900.
15. So how big is this piece right here?
30.
10, because the entire side we just figured out was 25. 15 plus 10 gives me the 25. Okay? Look at number 3. What should you think about when you see a picture like number 3?
Party hat.
A party hat. Very good. So this line is a tangent. Is this line a tangent?
Yes,
So
congruent.
how big is X? Okay, I'm going to give you just a couple seconds. I want you to look at 4, 5, and 6. All right. Somebody tell me what's this called right here?
Radius.
A radius? What's this side right here called?
Radius.
A radius? Let me ask you a question. Can I draw a radius right here?
Yes.
How big is the radius?
So,
How big is the radius?
30.
30. Okay. What can I call this line right here? Good. What do I know about a radius and a tangent? 90 degrees. So now what shape do I have right here?
Triangle.
So what can I use? Pythagorean theorem. 40 squared plus 30 squared equals c squared. 1600 plus 900. That gives me what? 2500? Take the square root of that. That gives me 50. So that means that this side right here, this whole side is 50, right? So this little piece right here would be 20, because 20 plus 30 gives me the 50. Okay? Number 5, what do we call this piece right here? Oh, but you can't see the black line, huh?
Radius.
Okay, what would I call this piece right here?
Radius.
How big's the radius?
41.
21? What's this slide right here called?
Tangent.
So what do you know about a radius and a tangent? 90 degrees. How big is this whole side right here?
30, no, 29.
29. So how can I find this one right here?
29 squared, 21 squared.
Well, remember, the one across from the 90 is your C.
Oh, yeah.
So it's 21 squared plus x squared equals
Plus
29 squared. So if I remember right, it's 441 plus x squared equals 841. Subtract the 441 from both sides.
400. Right?
Take the square root, so x equals 20. So what you got? Okay. Number 6, what's this line right here called? Radius. What's this line right here called?
Radius.
What's this line right here called?
Radius.
Okay, so those are all 5, right?
Yeah.
What would this line right here be called?
Tangent.
A tangent. What do you know about a radius and a tangent?
90 degrees.
They form 90 degrees. So how big is this side right here? 13, absolutely.
What's
So that means this one right here, this whole thing,
that?
8 plus the 5, is my C, right? So 5 squared plus x squared equals 13 squared. 25 plus x squared equals, what is that, 169? Minus the 25. So x squared equals 144. So x equals 12. That means this side right here is 12, right? Well, what did we call this line right here?
Tangent.
Tangent. What would we call this line right here?
Tangent.
What do you know about the party hat?
The congruent.
So how big is X?
12.
Are we okay? Questions? Okay. Flip it over to the back. Okay. In the last unit, we took a circle and put a shape inside of it. Now we're taking a shape and putting a circle inside of it. So somebody tell me, what kind of line is this one right here? Tangent. What kind of line is this right here?
Tangent.
Tangent. Is this a party hat?
No. Oh, yeah.
Yeah, aren't they two tangents?
That's really small.
Good. Same thing right here. They're just really small. Same thing right here. I have a tangent and a tangent that makes this a party hat.
You have a lot of party hats.
A little bitty party hat on a great big head, right? Are we good? So right here, do I have a tangent line and a tangent line? So if this piece right here is 6, how big is this piece right here?
6.
6. If this piece is 12, how big is this piece?
12. 12.
If this piece is 8, how big is this
8.
piece?
8.
Are we okay?
This is easy.
This is easy. So look at number 1. What would we call this piece right here?
Radius. Right?
What would I call this piece right here?
Diameter.
A radius.
Diameter minus.
So how big is the whole thing?
16.
16. Very good. Okay, they tell me that this piece right here is 4. How big is this piece? 4. So how big is this piece?
4.
Only because they told me it was a regular, which means that all the sides are the same. Are you with me? So every single one of those little pieces are going to be 4.
It's the same
So
party
it's
Well, yeah, but it's just asking for this little piece right here.
party hat.
Mhm. But you have to know the word regular in order to do that. So right here, what would we call this line right here? What would we call this blue line right here? Diameter. So how big is this piece right here? 6. So how big is this piece right here?
6.
This piece right here is 6. How big is this piece right here?
6.
This piece is 4. How big is this piece?
4.
So how big is the whole side?
10.
Party hats are easy?
I like this party hats.
I like this party hat stuff, right?
We should have a
Okay.
party to practice.
If this piece is 6, how big is this piece? 6. If this is 2, how big is this piece?
9.
2. So how big is the whole side?
And 8.
Last one. It says to determine, I'm sorry, I'm not finished. It says to determine if these lines are tangents or not. Okay, so let me ask a question. To determine if it's a tangent or not, what is this line right here? And what would this line right here be? And that means this has to be 90, would you agree? If that's true, then I have to know that Pythagorean theorem would work. So what that means is 14 squared plus 20 squared needs to be equal to 26 squared. Is that true?
Yes.
14 squared is
240.
169, I think.
No, that's 13.
196.
It's 196.
196? Okay, what's 26 squared?
4 something.
676.
676? I'm sorry. Is it true that 596 is equal to 676?
No.
So could that line really be a tangent?
No.
In other words, on your paper, were some of your numbers off on the yellow circles we were doing?
Yes.
The reason why they were off is because your lines really weren't drawn as tangents.
Oh.
Are you with me?
So that was easy to straighten out.
So, yeah, you just had to fix it a little. Is that okay? Sure. I wasn't looking for perfection. I just want you to know that if your numbers are off a little, it could just mean that it's not quite a tangent. And the reason on this paper we assumed on all the other ones is because it told us, assume that a segment appears to be tangent is tangent. So we made that assumption. Are we okay? They should tell you this to ensure you work it correctly. Have a great day. 2 pages.